Hey everyone, welcome back for lecture 3.5, module 4, RAD 103. Here we go. So we are still talking about grids, and we're talking about the technique associated with grids, because as much as we love grids because they improve image contrast, we can get some nice detail out of it, nice clean image. The downside of grids is that we have to increase the technique in order to get enough X-ray to get through that grid in order to make an image, so therefore patient dose goes up. So then the question is, how much more dose and what do we change? And of course we've got KVP and we've got mass. Now according to the book, the thing that's changed most frequently is going to be the mass, and I had mentioned this in a lecture earlier that when I was going through school, we didn't even consider changing the KVP. It was always the mass. And so making sure that I understood how much more mass is needed for the grids that I was using at the clinical site I was working at the time was important. And generally it was going to be either an 8-to-1 grid or a 10-to-1 grid. So, and I knew that it was a grid factor of 4 or maybe 5 for a 10-to-1 grid. And so I would just take my mass and times it by 4 or times it by 5, and so that was a pretty easy calculation. KVP is a little bit different because KVP, there's no pattern or rhyme or reason as far as I'm concerned looking at this chart. But as I read more and more in the book, adjusting your KVP is more of a very high grid ratio grid. So when you're up into like 12-to-1, 16-to-1, that's usually when you are going to increase your KVP rather than your mass. And I think if you did the mass with a 16-to-1 ratio grid, you're looking at adjusting your mass by timesing it by 6. That's a lot of mass. And so I think you're better off changing your KVP because you're going to have way too much dose for that poor patient. So increase the KVP. When you're dealing with higher grid ratios, the main thing to change is going to be your KVP. When you're down around 6-to-1, 8-to-1, 10-to-1, the most commonly used grids, especially if you're going to be using a portable, then I would just consider adjusting the mass. So that's what I would do. Now there is a chart that you can memorize, and it might be a good idea to have this formula in your head. I can tell you that this is a formula that when I got my whiteboard for the registry exam, this is one of the formulas I wrote down because I just wanted it. I just wanted to see it and be able to do it rather than try to pull it out of my brain. So this is one of the formulas I had. But this was easy. You know, most of the times we're going, okay, I tried that exam without a grid and it came out like crap. Now I'm going to add an 8-to-1 grid. What's my new technique? Simple. Well, what was your mass? It was 12. Okay, so 12 times 4 is 48. So there's your new mass. I'm all set for an 8-to-1 grid. So I knew all my grid factors. Again, are they going to ask you, if so, you started with a 5-to-1 grid and you're going to go to a 16-to-1 grid, what will be your new mass? That's where you need to use this formula. I think it's unrealistic, and I don't think you'll ever do that in a job. But you might want to know it just in case. Most of the time you're going from no grid to grid. I mean, that's pretty much it. So, so try that formula out. I think I've got questions on the next slide. Let's see what we got. Here are some questions. You can try them out. If you want, maybe we can do these together on a Monday evening or something whenever we get together and see if you get those right. But it shouldn't be too tough. So give it a try. All right, bringing it back to this slide because I just wanted to look at KVP. So again, the grid I'm used to using is an 8-to-1. So if I had to go up 13 to 15 on my KV, sure, I guess. But as mentioned earlier today, you all have a computer on wheels now. Your portable machines are so smart. There's a computer right there with software that tells you what your technique is going to be. I would trust that a whole lot more than me doing math in my head on the fly and adjusting my own technique. And I'm sure you all could say the same thing. The manufacturer has come up with techniques. You can see the different tags associated with the exams you're going to do. So yes, they have different techniques for different distances. So if you're doing a portable chest, Sometimes it says 70. There's one for 72. There's one for like 56 inches. It's a 50-something inch. They know it's not 72 inches at the foot of the bed. Yet, what are we taught when we're doing portable x-rays? Just put the portable at the foot of the bed. So they know to adjust the technique because of that SID. You know, are you using a virtual grid, or are you using a grid or no grid? And actually the tag will say no grid. So it knows what you, or it gives you so many options to choose the right technique. I think you're better off just using the right tag rather than you trying to do this math on the fly before you take an exposure. That's my thought. Should you have these memorized? I would have these memorized. I think I would have these memorized just in case. I mean, this is a new thing. I've mentioned this. This is a new thing. You know, will the registry or will board vitals? I'll see if I can find a board vitals question that goes over this. But maybe they are going to say, you know, you go from 0 to a 12 to 1 grid. How much do you increase your KVP by? You might need to know that. So, and I'm pretty sure I did come across that, which is why it's now on my slides. So I would memorize that. The fact is you have to increase your technique when you're using a grid. That's all there is to it. Okay, whether it be your mass, whether it be your KVP, whether it be both or whatever, you have to make more X-ray. You have to have more X-ray come out of the tube because too many scattered photons are going to be absorbed by that grid, and you'll have an underexposed film. You're going to have it's going to be too noisy, a lot of quantum model. It's going to look grainy. So therefore, you need to increase the amount of X-ray coming out of that tube. And you can do that again with mass or with KVP. So that's enough about technique. Increase your technique. So air gap technique. Let's talk about what an air gap technique is. An air gap technique is a way of omitting scattered X-rays by having the image receptor so far away from the patient that the scattered X-ray isn't able to touch the image plate because it's so far away. If you have an X-ray photon that goes straight through, it'll have no problem hitting that X-ray plate. If you have an X-ray photon that is scattered and goes off into a direction, granted, yes, it could scatter up and still hit the image plate, but a majority of them are not. A majority of them will either bounce back wherever, but a majority of them will miss the plate altogether. So do you get the same effect? According to the book, it's got the same effect of using an 8-to-1 grid, and so therefore it is pretty effective. There are downsides to this. We've got a lot of OID. When you have a lot of OID, you have a lot of magnification. The question is, do you then back your tube up? Now don't forget, if you back your tube up, now you're going to have to maybe adjust your tube technique because you're so far away. So there's a lot of variables that come into play. I have seen an air gap technique used. It does seem to work. The image is quite large, but you know, in a pinch, in a traumatic situation, if you got to use it, you can use it and it works. So you should be aware of what it is. You should be aware that the distance needed for this to be effective should be around 10 to 15 centimeters. Now I realize 10 to 15 centimeters may mean nothing to most of us, so therefore it's really 4 to 5 inches. So that's not that far, okay? Not that far. This is a good representation. It was often used with a C-spine. And you almost have 4 to 5 inches anyway, even if you had this image receptor up to the person's shoulder. But that's usually your problem, is the shoulder. The shoulder has so much width to it, so much girth to it. It's hard to see that the bottom end of the C-spine, which is really down into the shoulder area or upper back area. So anyway, now I'm just talking. So about 4 or 5 inches, 10 to 15 centimeters. That's what you're looking at. Same as an 8-to-1 grid. Pretty cool. And so that's pretty much it. I've covered everything that's on this slide. That is the last slide of the semester. Actually, this one is the last slide of the semester. So, guys, congratulations for making it to this point. I hope this makes sense. I hope it's sticking into your brain. If not, you need some help, you got to get a hold of me, and we got to figure out a way to make this stuff stick. Again, you're not going to get any material that's much harder than this from me. Russ is a different story, but Russ is an amazing teacher. He could make anything clear. So, but I'm available to help you guys in any way. Please utilize that, and we'll figure something out to make sure that you get this. And I will see you all at the next video conference, probably Monday evening. Write down your questions. Make sure you write them down and ask me, and then we can get this done. So anyway, amazing job, everybody. Excellent. It's good to see you all. I hope you enjoyed these videos. I enjoy making them. They're kind of fun, and I'm always learning stuff as I talk about it, even after 5 years of doing this. So I will see you all soon. See ya.